I believe this is section 4.3 in your textbook. As I said in the video that I posted a couple of weeks ago on a Friday, there are properties of logarithms, and I will go over those properties as we go along. If not today, in the video for Friday, I will summarize when I do a problem. So, key thing to note, we are going to talk about natural logarithms first, which is ln. So ln of x is the natural logarithm function. E raised x is the natural exponential function. And ln of x and e raised x are inverses of each other. What do we mean by that? Well, suppose we do ln e raised x. Instead of x, I am plugging in e raised x in a natural logarithm. The answer would be x. I tell my students an easier way to remember this is these two sort of go away, and you're just left with x. Formally, though, that is very incorrect to look at it that way, but an easier way to recognize that if you have ln and inside ln you have e raised x by itself, then the ln and the e would get cancelled and you're simply left with x. Likewise, if you have e raised ln of x, I've already mentioned that the natural logarithm and the natural exponential are inverses of each other. What do we expect to get here? These two were inverses, ln and e got cancelled, I got x. These two are inverses, what should we expect to get? X. So, again, I tell my students to think about it this way. Those two would get cancelled and you simply have x. Does that make sense? You may ask me, well, why does this matter? Both of them are useful in solving logarithmic equations and exponential equations. Suppose we have the equation e raised 2x plus 1 equals 5. The equation has exponentials, so this is what we call an exponential equation. And if we have an exponential equation, we can solve an exponential equation by taking logarithms on both sides. I'm going to say logarithm for the time being, but the base is quite important. If the base is different, we have to take a different base log, but we will wait for that until it comes later. So if we have an exponential equation, we take logarithms on both sides. So if I did that, I would get ln of e raised to x plus 1 equals ln of 5. Right? I take ln on both sides. What would happen to those two? Get cancelled. Easy way to remember. So those two would go away, and you simply have 2x plus 1 equals ln of 5. If I move the 1 to the other side, I would have 2x is equal to ln of 5 minus 1. And what should we do next? We divide by 2 on both sides. And that is the answer. You may ask me, well, what about this ln of 5? ln of 5 can be easily found using your calculator. If you have your TI-84 calculator, do we have it with us? No. So you can go look it up. I think I go over that in the video also. The ln button is the second log button. It's very close to the on button on a TI-84 calculator. So if you type ln of 5 in your calculator, you will get a number here, then the answer will be a number. Does that make sense? There are two ways to solve this problem. But the most effective way is to use natural logarithms because you can understand it better. So E here, E there. So I can directly compare the two, just the powers, and get an answer. So that's method 1. Since the bases are the same, I can set the powers equal to each other. So x squared minus 4 would equal to would equal to 3x squared plus 7. Move the x squares to one side, numbers to the other side. So we would have x squared minus 3x squared would equal to 7 plus 4, which is 11. If I move the 4 to the other side, I'll get 11. X squared minus 3x squared would be equal to 11. Divide by negative 2. We have negative 11 over 2. What is the square root of negative 11 over 2? Algebra. Can you take the square root of a negative number? No. But what is the square root of negative 1 in general? Think of an iPhone. Have we seen this before? A complex number. So the solution here is complex. Method 2 is no different from method 1, but we just start it in a different way. We recognize that it is an exponential equation, and since it is an exponential equation, we take logarithm on both sides. Yes? What would happen to ln and e? They get cancelled. Now, keep in mind, this is just an easier way to remember, but in reality, there's more to it. So if they go away, we simply end up having x squared minus 4 equals 3x squared plus 7. Yes? And that is the step that we started with. Does that make sense? In the video, I've mentioned this property that ln of 1 is 0. So keep that in mind. So I would like to know the solution for e raised 4x plus 5 equals 1. We'll give you a minute or two. Let's see if you can get it. So it is an exponential equation, so we take ln on both sides. So ln e raised 4x plus 5 would equal to ln of 1. And I just mentioned ln of 1 is 0, right? One of the properties. So that would be 0. What happens to those two? Goes away, right? So we would have 4x plus 5. 4x plus 5 equals 0. That is easy to solve. 4x would equal to negative 5. Divide by 4 on both sides. X is negative 5 over 4. Good? I'm going to introduce you to logarithmic equations, and then I'll stop and do examples on Friday's video because I have to run to that meeting. So an exponential equation contains the exponential functions. take a guess as to what a logarithmic equation would contain. An exponential equation contains exponential functions. A logarithmic equation must contain logarithmic functions. So these are the keys to solve a logarithmic equation. Very first step, even before you try to do anything else, check to see So before you start watching the video on Friday, which I'll be posting for Friday, make sure you go back and watch the video on the properties of logarithms, because that is the very first step. You've got to know the properties so that you can combine or cancel things out. And for instance, ln of 1 is 0. If you know those things, then the original logarithmic equation can be simplified. Once you do that step, with exponential equations, we took logarithm on both sides. With logarithmic equations, take exponentials on both sides. The fancy word here is exponentiate. Right? So, as an example, if I have ln of x plus 1 equals 5, that is a logarithmic equation. All I have to do is exponentiate on both sides. E raised ln of x plus 1 would equal to e raised 5. What happens to the e and the ln? They get cancelled. We will have x plus 1 equals e raised 5, which would imply x is e raised 5 minus 1. How do we find e raised 5? It's in the calculator.